Uh, Sorry for the few minutes of technical issues that we had, but we've gone live now, and welcome to this 11th webinar on the WEkEO DS. Today we will be talking about climate applications in WEkEO, and let me show you what we have in store for you. Um, we have a few speakers here with us today who will give you some insights on the Copernicus Climate Change Monitoring Service and how you can use it in the WEkEO DS. So with us today is Carlo Buontempo. He's the director of the Copernicus Climate Change Monitoring Service. He has been with ECMWF for many years already, previously leading the Copernicus Climate Change Service sectorial information systems. And before ECMWF, Carlo worked at the UK Met Office as a manager of the climate service team. Then we also have Julia Wageman, who is a geospatial data professional who develops and runs Jupyter notebook-based trainings on Earth system data. She's been working with Jupyter Notebook since 2014 and has developed several trainings already, including for the Copernicus Climate Change Service. From the WEkEO user support side, we have Amin El Amarani, who is a satellite imagery expert and a WEkEO user support expert specialized in technical issues. So if you have any questions about working with the WEkEO DS, about technical issues as a user, you can reach out to our support and you may get an answer from Amin. And then myself, I'm Anne-Catherine. I'm from the WEkEO user support desk. And I will be moderating today's sessions. We have a few presentations for you. We will start with a brief introduction to the WEkEO DS, the WEkEO website, and what you can find in terms of climate change data on the website. Amin will take over and explain more in detail the infrastructure that is accessible through the WEkEO DS and the pricing. I will quickly give you an introduction or an overview of any other data that might be useful for you in the WEkEO catalog. And then Julia will be giving you a live demonstration of climate applications in WEkEO. We will be gathering questions in the chat throughout the webinar, so please feel free to use the chat and ask any questions. If you have a question, there is a possibility to mark it with a question mark, so that at the end of the webinar, we'll have a 15-minute Q&A, and we can either answer those questions live or we will be answering them in the chat. If at the end you still have some questions left, or you are going to start working with the WEkEO DS and some questions come up, please don't hesitate to reach out to us through our web portal, through Twitter at WEkEO DS, or through the service desk email support@wekeo.eu. And then I will now give the floor to Carlo Buontempo to introduce the WEkEO DS.
Thank you. Thank you very much for your introduction. Let me find my presentation. Yep, here we go. So good morning, everyone. I am Carlo Buontempo, and I am the director of the Copernicus Climate Change Service. So it will be a very short presentation, mine this morning, and it will be more than anything else, a quick introduction to the WEkEO DS. And I guess good starting point for this presentation is basically to ask ourselves, what is WEkEO? And the first thing to mention in relation to WEkEO is that WEkEO is part of Copernicus. As you probably know already, Copernicus is the Earth observation program of the European Union, and as such is probably one of the most ambitious Earth observation program anywhere on the planet at this stage in time. One of the things this program does, and the program is divided into a space component that launches and manages satellite, and a service component that makes sense of this satellite information in specific sectoral context. And this environment, this Copernicus program, is very good at generating data. So of the order of 10 terabyte of data, of freshly new data is produced every day, and much more data is generated by the services themselves. So if you see these as a challenge, then you can think that part of the solution of this challenge is to have a mechanism to access this data, this huge data, process this data in a scalable way. So these are what we call the DIAs, the Data Information and Access System. There are several DIAs, and one of these DIAs, the one we are talking about today, is WEkEO. So this was just to give you a bit of a context. So there are several partners behind WEkEO. WEkEO is implemented by EUMETSAT, by the European Environment Agency, Mercator Océan International, and ECNWF, which is the organization I belong to and is the European Center for Medium Range Weather Forecast. So as you can see already, there's a lot of international experience in these agencies and organizations, a lot of European experience that has been put together. But more importantly, and I will stress this once more later on, these are the producer of the data. So there is knowledge, a very in-depth knowledge of the data that is being provided and how to use it and transform it. So what does WEkEO contain? So given the partners I was mentioning, you can expect all Copernicus data to be available on WEkEO. So these are the data coming out of the Sentinel, coming out of the satellite, as well as the data that is made available through the different Copernicus services, such as the atmosphere, marine, land, or climate change service. That is the one I'm most familiar with. So this data exists and is a unique place where you can mix and match and organize these different data sources. So on top of this data layer, there are services and support. So there are tools and to build application, to build workflows, and we will hear more about it later today. But there is also user support that is fundamental, as we learn over time, in managing the user expectation and responding promptly to user queries. So I don't want to take too much of your time. I just want to give you a few examples of the kind of information you will find on WEkEO that are coming from the climate change service. The first data set I want to mention are the reanalysis. So if you're familiar with the reanalysis, well, there is not much to say. If you're not familiar, it's basically a rerun of one of the most recent version of the weather prediction model that we use every day to make weather prediction over the historical period, using as much information as possible. Also the information that at that time wasn't available to make weather forecast. So this is a way of generating what we call maps without gaps. So for any place on the planet, back to the 1979 for the ERA 5, and back to 1950 even for what we call the back extension of ERA 5, it's possible to characterize at hourly level any meteorological variable. And this is fundamentally important for a vast array of applications. So what I show here are a few examples based on ERA 5 of this reanalysis that have been used for the monthly climate bulletin and the state of the climate report that we produce every year in April. So for instance, you may have heard, may have read yesterday on the news that the summer was the European last summer, so June, July, and August of 2021, were the warmest of record, even if by a very small margin. And this was a news we published yesterday, which was based on this data set. So this is the first data set, and it's also the most popular data set in our portfolio. Just to give you an idea and to stress the strength of the approach of WEkEO, the data set as a whole is in the order of 8 petabytes of data. So you clearly need an infrastructure, a dedicated infrastructure, to make sense and transform this data into something tangible and usable. The second data set I want to mention that is available through WEkEO are the seasonal predictions. So these are predictions for the next 6 months. These are coming from a set of prediction model. So not just the one at ECNWF, but also the one of the World Meteorological Organization global producing centers based in Europe, such as Météo France, Met Office, CMCC, DWD, and also some contribution from outside Europe, such as the American model, the Japanese model, the Canadian model, and possibly in the near future also the Australian model. This is an information. The seasonal prediction is an information that is best used looking also at the historical um, performances of the forecast system to extract the signal, the predictable signal. And the kind of product that are all probabilistic in nature that you can get out of this data set are those that some of those you can see here. For instance, the likelihood of being above or below the usual temperature in certain part of Europe for the next few months. So upper tercile and lower tercile of the distribution, or in the bottom plot, the probability of being wetter or drier than usual at the global level. What you see on the left, bottom left, is one also of the most powerful example of the power of this data set, and is the El Nino plume. So predicting what the temperature in the central Pacific will do in the next few months. And this is, as you know, fundamental in controlling a number of climate impact globally. The last data set I want to mention are in this case, the sea level daily grid data from satellite observation. And I picked this one because it's available on WEkEO now, but I took it almost as a reference to a much wider set of data set. And these are the satellite observation, the essential climate variable, as we call them. So the proposition of the Climate Change Service is very much built around this concept of GCOS, the Global Climate Observing System, of essential climate variable. So at the moment, we have 22 of those variables. We plan to increase those in the next few years to reach hopefully something in the order of 35. And they cover the land surface, the ocean, the biosphere, and the air, and so on and so forth. So in this case, I'm just mentioning the sea level. Sea level is a variable that is very significant in terms of controlling the impact at the local level, as you can see in this image on the bottom left for Ireland, and it will become more and more important in the future, as you can see in this case, one of the example out of the C3S portfolio, and it's about the changes in the tidal range, partly attributed to changes in the sea level. So I don't want to spend too much time. I was just keen to give you an example of what C3S is offering. And you will definitely hear more later today about some of these data sets, especially reanalysis, which underpin many of our applications. I just want to stress once more some of the unique feature of WEkEO. And for me, probably the most important is really the consortium that is behind this data. So behind this infrastructure. So Mercator Océan International, ECNWF, EUMETSAT, and the EEA are very much the producer and provider of this data. And so they are very close to the data and can provide an added value to the users. Another important and unique feature of WEkEO is the fact that the data is not a copy. The data is not copied into yet another online archive, but is rather a distributed system that take advantage and build upon existing infrastructure. So this means that there is a direct connection with the data and allows traceability to the data, but also allows for a constant update and linking up to the most recent data set. The final point I want to mention, and again, there will be presentation following this introduction about this, is really the importance of focusing on the user. So user development on the one hand, but also user support on the other. And this, we have seen it even within the climate change service, that one of the features that makes the service really operational and is really appreciated by the user is the fact of having truly responsive user support that is able to follow the user queries and respond in a timely manner. So this user support at WEkEO is structured in two levels. So level one support operated by a dedicated team, and try to be as responsive as possible, providing relatively, or responses to relatively simple queries. But at times, the kind of question, the kind of request are more technical, more data related. And for that, there is a level two support that is operated by the senior expert at the different entities at the different partners level and their contractor. So that's the way it is structured, and it's very much a fundamental element of the program. So I just don't want to take too much of my time, and I really want to close wishing you a great workshop and a successful workshop. I just want to highlight here the links to the WEkEO portal and to the service desk for your reference. Thank you very much for your attention.
Thank you, Carlo, for this introduction. Let's continue with the infrastructure and the pricing by Amin. Good morning.
Yes, good morning. So I will share my screen. So I said good morning, everyone. My name is Amin Lamrani, and I'm part of the support team of WEkEO. So I'm going to do a brief presentation of the IT infrastructure of WEkEO, which consists of two main services, Jupyter environment and the virtual machine. So it's been a few months since our new WEkEO website is now active. So as you can see, there is this more intuitive design. There's a documentation section that has been revisited very recently. So I strongly recommend, even for the familiar, with people who are familiar with WEkEO, to go and see the new articles that are in the documentation section and the FAQ. So let's start with the Jupyter notebook. All you need to do to have access to Jupyter notebook is to register to WEkEO, to create a WEkEO account, and then once done, you can sign in, as I do here, and get access to the WEkEO account. So then afterwards, you get to click on the dashboard button here at the top of the page, which brings you to the Jupyter Hub by clicking here. So what is the Jupyter Hub? What is the Jupyter Notebook? It's an open app, open source web app that you can use to create and share documents that contain live code, equations, visualizations, and text. And this is the welcome page of the WEkEO Jupyter environment. You have access to a classic Python interpreter. You have also access to a terminal, because the Jupyter environment is some kind of a small virtual machine. And you can also create a document from scratch, a notebook document from scratch, if you want to create your own document. But we recommend you to start from the document that is already available in the public folder. Then by clicking the WEkEO HDA, and you have this WEkEO Harmonized Data Access API document. So as you can see, the Jupyter environment allows to have text to explain things, but also images, and more importantly, these code cells, which allow you to, by clicking the play button here on each code cell, to execute some Python code exactly as if you were on a Python interpreter. And why I have chosen this document, because it contains all the introductions to how to reach the WEkEO data, to download the WEkEO data on your environment, and to make some processing on it. You just have to follow the text and click play on each code cell, and you can also modify the code cells, for example, to put the data the data descriptors that you want, that you get from the catalog to download the data that you need. So the outcomes and results of the code running are also displayed in the document itself. For example, if you have graphs, the drawing of the graph will be shown on the Jupyter notebook itself. And at the end, you can also save the document uh, to a PDF. For example, if you want to keep a copy of it without using Jupyter afterwards. So getting familiar with these documents, especially this one, will make you very comfortable with the Jupyter environment very quickly. And you can afterwards go and see all the other documents that are available. And you have also all these teams that were already treated on other um, webinars that you can find on the WEkEO YouTube channel. So now we will talk a little bit about the virtual machine. Some of you might ask, why would we need a virtual machine? As I was saying, that this Jupyter environment is also a virtual machine. But know that these Jupyter environments are limited. They're not meant for advanced and resource-demanding processing. Storage capacity is limited. The CPU and memory are also limited. It is ideal for testing, mingling with data, but not meant for heavy processing. So there has been, though, an improvement on the Jupyter environment these last weeks, where you have now 4 CPUs and 16 gigabytes of memory that are available. So it makes it better, but we still need the virtual machines if we want to perform heavy processing. So how do we request a virtual machine? The Jupyter environment is free and is accessible directly once you have a WEkEO account, but the virtual machine, you should go at the end of the page and click this upgrade plan button here. You can choose the plan size, and you can also give us some information about the Copernicus data that you might need to download and use and process. And at the end of the page, you have this this table that contains the fee for each plan, and also the configuration of each plan. If you want a better table, you have this pricing section here, where you have a wider table that contains detailed information. And you have also these trial periods, which are available for each plan. So 5 months for this small virtual machine, and 1 month for a bigger virtual machine. So different pricing for different plan. And know also that these trial periods are indicators only. They can be negotiated, so to say, on a case-by-case basis. If you contact us on support@wekeo.eu, we will put you in contact with the commercial department of WEkEO, and they will see what you can do about it. Once these resources made available for you through the support, we advise you to follow this documentation section here, especially the parts about the virtual machines. And if you follow the articles and all the data that is available here, you can create your own instance of the virtual machine and use it as if you were on your personal computer through a terminal with this high-speed capacity and large computing capacity is offered by WEkEO. So yeah, if you have detailed questions, I would refer you to the webinar number 3 that is available on the WEkEO YouTube channel. There is a demo on how to download WEkEO data, very detailed demo, and also to download to download the WEkEO data on the Jupyter environment and also on the virtual machine. So that's all from me. Pass it over to Anne-Catherine. Thank you very much.
Thank you. I mean, it was very useful explanation of the infrastructure and the pricing. I'm just going to quickly give you A little bit more information, as Carlo already mentioned, the WEkEO DS contains all of the Copernicus data and information from the different services from the Copernicus Sentinel satellites. And just for completeness, so that you know that you can use these data as well, besides the climate change data that have already been presented, I just wanted to show you this. So we have the Copernicus Marine Environment Monitoring Service, which provides information on temperature, waves, currents, sea level, but also nutrients, turbidity, chlorophyll, and sea ice in specific regions. For seas and oceans close to Europe, but also for the global ocean. And you can find it both for the past, but also present observations. They're daily updates, as well as forecasts for the future for all of those parameters. Then you have the Copernicus Land Monitoring Service, which provides you with detailed information about land use, land cover, globally at a European level, but also at a high resolution around river basins or rivers around urban areas. So you can get that information and use it as reference data for any kind of application that you may be developing. And then besides then the Copernicus Climate Change Service and the Copernicus Atmosphere Monitoring Service from ECMWF, you also find then the more raw data from the Sentinel satellites, both from Sentinel-1, 2, 3, and 5P, and soon as well from Sentinel-6. Those are usually separated in between the Copernicus Open Access Hub from ESA and the Copernicus Open Data Access from EUMETSAT. But here on the WEkEO DS, you can find both of them in one place. And if you want to find those data, you can find them on top of the websites when you go to wekeo.eu. And in total, there are over 200 data sets available in WEkEO, and that does not, so those are the data, the types of data themselves. And then for those data, you still have time series going back in the past, or looking towards a few days in the future with the forecasts. You also have a viewer that is available. So if you want to check out some of the data before downloading them, before working with them, there's a very easy way to visualize data over even like European-wide areas. And just because you're all here to learn about how to work with climate change data in the WEkEO DS, I will now hand it over to Julia, who's going to give you a practical demonstration on how to use the data.
Thank you, Anne-Kathrin, and also a warm welcome and good morning from my side. My name is Julia Wagemann, and the next half an hour, around 30 minutes, I will give you a practical introduction to the climate data, to Copernicus Climate Change Service data on WEkEO. So I will specifically show you two different ways how you can access the data, and then a small example how you calculate climate anomalies to better understand also the benefits of the ERA 5 reanalysis data. Before I start, I just start sharing my screen, and then we can start. So as Amine and Anne-Kathrin already introduced you to the overall WEkEO system, and also the way how you can have a look what type of data are available, I will not go into details. I just, here, this is the WEkEO site. I just want to remind you that, yeah, you can sign in, and once you're signed in, you go to dashboard, and the dashboard allows you to give you access to the Jupyter Hub interface. And this is where I am here now. So I logged in, and then I went to the Jupyter Hub interface. and then you probably see only two folders in your folder directory, a folder which is called public and another folder that is called work. And if we go to the public, this is also what Amine already showed you, there are all the publicly available resources and training content available for you to see the benefits of WEkEO and also the different type of data WEkEO offers. And so the content I will show you, which you see here already in the main window, is available in the climate folder. And there you have a set of different Jupyter notebooks already prepared and available for you. The one we focus today is the one with training number 2 and climatology is new. So this one I will go through today, but I also warmly invite you to have a look to the other notebooks, and because they are all step-by-step guides on showing you how to process data, how to retrieve data, etc. And with this, and then one important aspect is as well that basically if you open a notebook from the public folder, this is read-only. So you cannot make any changes to a notebook you open from this folder. But this is actually the benefit of Jupyter notebooks, that you can also play around with the code, you can make changes, you can change the color scales, etc. And for this, I recommend you to copy the notebook you want to go through into your workspace. And so this is what I also did here. And so I copied the notebook for today into my workspace, and then I can also make some changes, and I let it run from there. And with this, you can open with a double click the notebook. And the tutorial I will show you is focusing on the ERA 5 reanalysis data Carlo mentioned as one of the most popular data sets from the Copernicus climate change service. And I will show you 2 examples how to access the data. So one example, how to access the data via WEkEO, or there's also, in case of data that might not be available yet on WEkEO, I also would like to introduce you to the CDS API, which is a Python package which allows you to also download data from the Copernicus Climate Data Store. And with this, I would start to go through, first showcase you how you can access data with the HDA API, with the Harmonized Data Access API, which Amine also already presented you. But before that, the tutorial also, we said a package that is not pre-installed, and if you want to use the CDS API, here you have the command. So you have ! and then pip install CDS API, and with this in your local workspace, the CDS API is installed. There is also one caveat. So any package you additionally install to your workspace, once you log off, you have to reinstall the package again. And so basically for the second example, we will need this Python package CDS API. And then we start, as if you're familiar with Python, in a common way, that we import important libraries. So you see here already, so we import the package we just installed. Then we make use of NumPy and Xarray, which are 2 packages that allow us a very efficient processing and handling of meteorological and climate data. For visualization, we make use of a combination of Matplotlib and Cartopy, and some other packages that are useful to go through the data access. And so the first option is the WEkEO API, or it's also called HDA API, the Harmonized Data Access API. And the first step is to define the data set ID we are interested in. And so just to show a practical example, what Anne-Kathrin already showed. So I went to the WEkEO website. You can go to data, and then you have here the interface. Per default, there are already example data loaded. But you can go here to the plus sign, and then you see the full list of the 225 data sets available. And the data from the C3S, so from the climate change service, you can hear this is already like a filter available for you, and you see all the data sets specifically from the climate change service here listed. So the ones that are available via WEkEO. And the ones we introduce here today is the ERA 5 reanalysis, and this is available as hourly data, but for many climate applications, it is also useful to already work with monthly aggregated values, because otherwise the hourly data, as Carlo said, they're quite large in volume. And so the climate change service already offers also monthly average data on a global grid. And this is the data we use today. So the ERA 5 monthly average data. And so if you expand here, so you get here more details. And so if we open this, you get some more information, but at the same time, you can here see the information we need for accessing the data. And this is the dataset ID, which we also have here in the Jupyter Lab defined. And so we have the dataset ID, and the next step is then to get the WEkEO API key, so to signal the system that we want to access data, and this is based on your username and password. And the example here already makes it very easy for you, so you just have to copy paste your username and password, and then your API key is generated. And once you generated your API key, then you can initialize the harmonized data access API request. As a start, this is also what I did. I created an additional data folder. So the folder is called data. And I say all the data I download, I want to store in this data folder. And this is also what I prepared already. So if I go here, there are the two different data sets with the two different ways already in the folder. And then basically there are some steps which you're guided through to initialize the request based on your username, password, and also the folder where the data should be stored. We request the access token, so the system allows us to access the data. In case you haven't used the API yet, you have to accept to the terms and conditions. And then the next step is to load a data descriptor file, which is basically additional information. So we already provided the dataset ID, but additionally to the ID, we also need the additional information. So do we want to have the data for a specific geographic location? For what time period do we want to have the data? For which month, which product type, which variable, because ERA 5 reanalysis has quite a few variables. And this is what we specify here in this data descriptor file. And here we see we want to have global data, we want to have the data in NetCDF. We have monthly information because we want to have the monthly average reanalysis data. And then for the years from 1979 to 2019. And then we can load this data descriptor file, which is in principle a Python dictionary. And in this dictionary, all the information is stored which WEkEO needs in order to retrieve the data. And then we can initiate a request. The request is sent to WEkEO, and once the request returned a result or a response, the status is completed. And then we just list the final list of data that has been brought from WEkEO to us as our data file list. And once we have this list, we can create for each of the files an order ID. And with these order IDs, we can then say to WEkEO, please download this data. And this is what I already did, because for the demo, we wanted to have already data available. But I invite you to go through this step and also familiarize yourself with these steps, because this is the same principle applies for any other data that is available on WEkEO. The second option is specifically also for data that might not be available for data from the climate data store that is not available on WEkEO. I would like to also show you how you can make use of the CDS API. So just a short introduction to the Copernicus Climate Data Store. You can go to cds.climate.copernicus.eu, and there you find any information related to data from the Copernicus Climate Change Service. And if you go to data sets, then you see here all the available data sets. If we look specifically, for example, for the data we're interested in today, to ERA 5, you see all the different ERA 5 data sets available. And so as an example here, again, we have our hourly data on single levels and on pressure levels, but also the monthly average data on pressure levels, but also on single levels on the surface. And I just have to find the one we're interested in. One moment. This is land. Okay, on pressure levels and ERA 5. Yeah, this is from here. Here's monthly average data on single levels. And there you get a very detailed information what ERA 5 is, how it also has developed, also data descriptions, and also all the variables that are available under ERA 5. And today we only focus on 2-meter air temperature, but of course we have many variables available, including wind, total precipitation, and many meteorological parameters. And if you go then to download data, here, this is like an interface that makes it easier for you to specify also the type of data you're interested in. So you can specify the variable you're interested in, then the year, the month, the time, and also you can, if you're interested already, subset the data if you're not interested in a global field, but only for a specific geographic region. And important is that if once you specify it, so let's go through the default information, you can get the data either in GRIP or in NetCDF. You can accept the license, and then here below you can either submit a form and download the data, but then the data is not in WEkEO. It's downloaded locally, but you can here you can see here the API request, and this is important, what you need for the CDS API. And so this is, I wanted to just show you how you can retrieve for any other data also the API request in order to use the CDS API. And now we go back to WEkEO and the Jupyter Notebook. And so basically what the API is needed. So at the beginning, we loaded already the CDS API. And we also linked a web link to how you can make sure that the API also works, because you have to also save your user ID and API key to a document on WEkEO, that the API also knows that you are authenticated. And here we already make it easy as well, that you just have to. So if you follow this link, you log into the Copernicus, to the CDS, to the Copernicus Climate Data Store, then you will see your unique user ID and also API key in order to retrieve data, and you just have to replace this information here. And then we also provided you an overview on how you can search for data. This is, I already showed you. So we are interested in, or the data we want to download now is monthly average reanalysis, 2-meter air temperature from 1979 to 2019 for all of the months and the whole available region, so the global fields in the NetCDF format. And once you have your API request, and this is the API request for the data we're interested in, we first load the CDS API client, and then we can define our retrieve request. And with this retrieve request, we can just also specify, please save this data in the data folder under this name. And this is what we did. So we have here also a NetCDF file with the identified name. And so here, please also feel free to request or to look for different data sets and also play around with a different type of data and to retrieve different type of data. And with this, we have our data with two different ways. We start reading the data now from the data we retrieved from the WEkEO. And so here we specify just the folder where the data is stored. It is in NetCDF. And we will make use of the Python library xarray, because this is a package that makes it very efficient to work with multidimensional
Julia?
arrays. Yes?
Sorry, your screen share disappeared.
Oh, okay. I stop and try sharing it again. Apologies.
Oh, perfect.
Is it working now again?
Yes,
yeah?
Thank you.
Okay. Okay, so basically we are about to read the data. So here we specify the data folder, and then we open the data set with the xarray function open_dataset. And what this function is doing, so this this function can read NetCDF files, and we give to this function the path to the NetCDF file, which we downloaded from WEkEO. And once we have it, then we have a xarray data set is created. And this is what we have here. So we see here it is an xarray data set, and it gives us additional information. So we see the dimensions of the data, which we see it is a 3-dimensional data set with latitude, longitude, and time. So monthly informations from 1979 to 2019. We have for each of the dimensions as well coordinate information, and we have one data variable. And this is the important to know for the xarray library, that a data set is more a collection of different variables. So the data set could also hold more than one variable. In this case, we only have one variable, but it can also hold many different variables. And the data set, we cannot work on the data set level, but the data set level gives us more information on the data set in general, and to have a first peek into how the data set is structured. if we want to work with the data and with the data array, which is with the 2 meter temperature information, we have to load this data array. So we have to load this specific data variable, and we can do this by adding the name of the data variable into squared brackets. And once we do this, then we load the underlying data array of our 2 meter air temperature. And here, and the difference here is now that we really also have access to the real data information. We still have the same dimensions, so time, latitude, and longitude, but we also additionally have additional metadata information. So we know the long name of the data variable and also the unit, which is in Kelvin. And so now we can start to work with the data and also to aggregate them to create some anomalies of 2 meter air temperature over the entire period. And the first step is to create a variable with the yearly means. And and this is also the nice thing with X-array, that we have already very efficient functions that help us to work with climate data. And so, for example, here we want to say, so we use the function group by, and we specify the dimension time and then specifically the year. And we want to say that we want to create an average for each year of the 2 meter air temperature. And this is what we do here. And the result is, in fact, that we have for each year the overall average 2 meter air temperature of the entire globe for each year from 1979 to 2019 in Kelvin. And the next step is then that we can calculate the mean temperature for a reference period. And in the climate analysis, any anomalies or a better understanding also of historic data, we always have to put it to a specific reference period. And a common reference period currently it's usually a period over 30 years. It's also called a climate normal period, and this is and the reference period that is usually taken at the moment is going from 1981 to 2010, and this is what we create here. So we want to also create the average of 2 meter air temperature for this specific reference period, because this is the reference value which we want to compare all other yearly averaged values against it. And this gives us an indicator also for global warming, for example, in what years we also had exceptionally high temperatures compared to the reference period 1981 to 2010. And so with the function, X-array function where, this is like kind of a function that helps us to filter data on any dimension of our data array. And here we filter our data array on the time dimension, and we see, and we want to have all the yearly information from 1980, or which is after 1980 and before 2011, and all the other years we want to remove from this variable, from this reference variable. And then in the next step, we create, for this 30-year period, we create an average, which is like the global 2 meter air temperature average for this reference period. And this is what we do here. So we have for each of the pixels the final global reference 2 meter air temperature available. And this is where, for now, for the next step, we can also, for example, visualize now this reference 2 meter air temperature for globally. And we can see, for example, a strong latitude gradient, and also the cold regions, and also here the Tibetan Plateau, for example. And the next step is now that we want to plot a global time series of annual temperature anomalies. And these are defined as deviations in temperature from the reference mean. And here we basically calculate the global mean for the reference period, and also for the for the annual data from 1979 to 2019. And here, this is our global 2-meter air temperature value. And the next step is that we also for we want to repeat the same step also for each of the years. We also want to have one 2-meter air temperature averaged value. And this is what we do here. So the result is we average it over longitude and latitude, and the result are 41 values of averaged 2-meter air temperature information. And then the last step is that we can create the anomalies. So we subtract the global mean for the reference period from the annual means. And with this, we see if compared to the reference period, for one specific year, the temperature was lower or higher. And if we, in a last step, also plot this information, so we plot the global anomalies for each year, and we also compare it to the reference period, we see that we have compared to the normal period 1981 to 2010, we see that we have a strong increase in increasing global air temperature values. And so we see a clear trend here. And with this, I would conclude for today. I said, and I also warmly invite you one more time to go through the notebook itself, because we also provided you another analysis which analyzes more a region over the Arctic. And yeah, the material is available for you, and please have a look and work through the examples in your own time. And I hope you found this introduction to climate data today useful and of benefit for you. Thank you. And then I will refer back to Anne-Catherine.
Thank you very much, Julia, for the demonstration. I've already seen some messages that it was a very, very good demonstration, good presentation in the chat. Okay, we also had some questions coming in. Lots of hellos from people participating. Very nice to see all of you here. Let me see, questions. The first question came from Hursit. He asked, is there any data or layer about past climates? I mean, data like early Holocene, for example? Yeah. Oh, you're on mute.
Sorry, could you please repeat the question?
Is there any data or layer about past climates? I mean, data like early Holocene, for example. Yeah.
So it's so the reanalysis data which I showed you today is it is now available. It's even going back to 1950. But so from the Copernicus Climate Change Service, as much as I'm aware, I think before 1950 is quite challenging. But ERA 5 reanalysis is available now from 1950 up to almost real time.
Okay, thank you. Holocene. Okay, yeah. Sorry. The next question asked about the difference between the WEkEO and the Copernicus Data Store, because it looks similar on like data and virtual computing resources.
Shall I give?
Yeah, sure.
Yeah. So the difference is basically the Copernicus Data Store is a shop basically. So you can go there and you can have a look to the data. And if you're interested in the data, you can download them to your local machine. What WEkEO, so the benefit of WEkEO is that it also gives access to the same data from the Copernicus Data Store, but it also gives you access to a variety of other data sets available as well. And this is quite helpful to also combine different data for specific applications. And additionally, WEkEO is a cloud environment. So as Amine showed you, you can also start your own virtual machine and you can also compute data there directly, which the Copernicus Data Store currently doesn't offer. It just provides you an overview of what data is available for download.
Okay, thank you. We have a more technical question regarding the method that you used, how you configured the passwords.
Yeah. Yes. So basically, I just see that this is the problem. This is the error related to read-only file system. So that basically you probably work in the public data folder. So you have to work in your work environment, and then you can go. So yeah. So basically, you can go to the Copernicus Climate Data Store. You can log in, and if you once you're logged in, you follow the link which I provided you. Then you see in a code shell, you see your UID and password, which you have to set in the notebook. But this error is related to that you're in the public data folder and you have to copy the notebook to your workspace.
Yeah, and by work environment, you mean the folder where we.
Yeah. If I share this again, exactly. So basically, you probably see public and work, and so once you are in public and I open a climate. Like a climate here, like the notebook here, I can't make any changes. So you see here that basically the save button is grayed out. So I can read it, and I think I can also execute it, but I can't make I can't save any changes. And so what I recommend you is to bring any content you're interested in. So if you go to the main folder here, so if you click on this folder again, then you are in your home environment. And this is your working environment where you also have write access. And this is what I did as well. So you can either copy it via the terminal. So you open here, if you go to the plus sign and you open a terminal, then you can just with the CP, you can copy any content from the public folder. Or if you go to the public and you go to here and you do right click, then you also get a menu and you can say copy, and then I can here say paste, for example. I think, yeah, and now I have this copy here. So this is one way or two ways how you can bring the content to your work environment.
Thank you. Perhaps a question for Carlo. Wait. Does air pollution differ from the data from the climate change service?
Say it again.
So does air pollution differ from the data from the climate change service?
So, well, okay. The way how can I address this question? So, in the one hand, there is a dedicated service of Copernicus, the CAM service, that is devoted to atmospheric concentration and monitoring, that provide information on specific pollutants, and so this information is also available through WEkEO. Now, the climate change service as such provide information on some trace gases that are relevant for the climate, and some of them are also pollutants. So it's not in the definition of what is a pollutant and is not sharp. So if you look at ozone, it can be considered a pollutant, and it's also a very important trace gas in terms of its relevance for radiative transfer and the greenhouse gas, and so is methane, for instance. And those are the kind of data set that we do make available through C3S and so through WEkEO. I guess often the major difference is what is the scope. So on the one hand, you may want to look at short-term forecast for air quality purposes. On the other, you are more interested in the long-term trends and consistency over long periods.
Thank you. Excuse me. Are there any products for agricultural applications, perhaps specifically linked to climate?
Yes, there are. I guess even here it is worth dividing between two categories. I didn't get into this the level of details in my presentation, but on the one hand, we have what we call the fundamental data, the ECBs being also the essential climate variable being one, but also the reanalysis and so on. And on the other, we have applications of this data. So in terms of this fundamental data layer, some of it is directly relevant for agriculture. So if you look at precipitation, temperature, and so on, and you can look at the temperature exceedances or accumulation of precipitation, and so on. In the last few years, we developed a series of examples on how this fundamental data can be transformed to be more relevant for agricultural application. So there are dedicated data set and dedicated workflows that look at growing degree days or exceedance of threshold that are phenologically relevant, pollen, and so on. But I see those as a add-on layer, more as the result of a workflow rather than a fundamental information as such. But these are available on the C3S website, and you can look at those.
And could you also say a few words about the role of Mercator Océan in the WEkEO DS?
Well, I guess there are other presenters from Mercator Océan who are a better position to answer this question than myself. But one of the key elements of Mercator in the DS is really to taking care of this user interface and the user engagement. So that's something they bring to the table on top, clearly, of the data itself. So we have all these services providing data, and there is a very close collaboration between the climate change service and the Mercator Océan and the CMEMS, the ocean service, in relation to the ocean variables, for instance. So there is a strong cooperation, and I think these are probably the two top level elements worth mentioning here.
There was, I'll answer this question quickly. So this webinar is being recorded. It will be available on YouTube later. You will get a link after the webinar. When you go to the WEkEO YouTube, you will see several webinars, trainings that have been recorded so far. So if you want to have a look at the basis tutorials on how to get started with WEkEO, how to use them for several thematic applications, you can find it all there. I'll have another question, but this is very meteorological. So either Julia or Carlo, can you answer this question on the use of or the availability of synoptic data series for verification purposes?
I'm happy to give it a go, if you want. Normally, it's more difficult to get station data than other form of data. So synoptic data is not always easily available. So for Europe, we make available gridded data based on observations, such as the EOPS dataset. But we put also an effort in trying to, in putting together a extensive data set of observation, not just in Europe, but then anywhere on the planet, of surface observation. So these are ocean and land observation, and these are available at station level. Not all the SYNOP are available because there are restrictions, and it's always a work in progress in trying to free more and more data, and we definitely work on it to make even more data available in the future.
And we have one final question, a very specific one, not directly related to the climate change service. So I don't know, Amin, if you can also help out whether the ESA OCCCI nutrition chlorophyll A data is accessible from the WEkEO with the API.
Well, actually, we just have to look on the catalog. There is a filter that allows to search for keywords. So if you use the keywords and they're not available, the product is not available, it means that it can't be accessed by WEkEO.
I can add as a general comment that WEkEO only includes data from Copernicus, and the difference between ESA data and Copernicus data is Copernicus is an operational program. So it is committed to certain quality controls, to certain service level agreements, etc. While some data developed by ESA can be imported into your Jupyter notebook to be worked upon, but it's not operational in the sense it's for scientific purposes, etc. So normally ESA data sets that are not labeled Copernicus are not part of the catalog, generally speaking. That's why also satellites that are not yet fully, which are like explorers, like Cryosat or Aeolus for winds, etc. That data you can import it with your own, well, by copying it, etc. But it's not in the data catalog because the data catalog is part of the operational service delivery of Copernicus.
Yes, and to import the data, you just can drag the file directly into your Jupyter notebook, and this can be uploaded and used using the usual tools that we have. And if you have any question, we can answer for specific non-Copernicus data.
Okay, thank you all very much. Thank you to the speakers for the presentations, for the demonstrations today, for the answering all of the questions. We will now be ending this webinar. Make sure that you attend the next webinar in 2 weeks on the 23rd of September related to business applications on the WEkEO DS. And if there's any questions after the webinar, don't hesitate to reach out to us at support@wekeo.eu. Have a nice afternoon, evening, and bye.